Okay, YouTube, in this third video that I'm making on solving quadratic equations, we're going to focus on how we solve these by the method of factoring, okay? So we say that when the left side of this equation, where we have our quadratic equation in standard form, ax squared plus bx plus c equals 0, when the left side is factorable, we can actually solve this equation using a very important property we call the zero product property. And so before we use that method over here, which is a pretty quick method, we're going to take a look at what the zero product property is. So we say in words, if the product of two expressions is 0, that is, if we take two things and multiply them together and we get 0, then one or both of those expressions were equal to 0. And that's kind of intuitively obvious, but algebraically we're saying if a and b are just expressions, some expression in terms of, say, x, if we were to multiply them together, which says the same thing we set up here, and get 0 for an answer, then either a equals 0 or b equals 0. So what we want to do is kind of point out how that's a useful thing when we talk about quadratic equations. Now, starting with the fact that quadratic equations are often solved by setting them equal to 0 in the first place, it's important to notice that this is already set equal to 0. This zero product property does not work unless it's set equal to 0. But what we'll do is we'll attempt to factor this trinomial, which, as a matter of fact, let's give this a shot here. We'd say, can we think of two numbers that multiply out to be a 32 that add up to be a -4, and this is a -32. So if I said, well, if they're negative, one of these is positive and the other one here is negative, and we could say, well, a -32, they must be 4 apart from one another. If one's positive, one's negative, they add up to be a -4. So I suppose I could think of a -8 and a +4 would do this. We say -8 and a +4. What I want everybody to see is we've gone from an expression that said something minus something equals 0 to something times something equals 0. So this is really our A expression and our B expression, and because we could say that they multiply out to be 0, it's very easy to see that we could now just say, well, then either x plus 4, either that's equal to 0, or x minus 8, that's equal to 0. One of these is equal to 0, or both of them are. So solving this now, this is a whole lot easier than solving the initial equation on its own. We would say that we get x is either -4, or we would say in this case x, adding 8 to both sides here, x minus 8 plus 8, we get x is 8. And so these are our two intercepts on this graph, as a matter of fact. I want you to notice that when we factor this, we really did put this into intercept form, but we'd say -4 and +8. Those are actually the solutions as well. So it's very easy to check. Plug both of these back into the original equation, or even the factored expressions, even easier, to see that plugging a -4 right here would give you -4 plus a +4 is 0, and the whole thing goes to 0. Or plugging the 8 in right here, we get 8 minus 8 times all of this stuff would be 0 times all this stuff, which goes to 0. So looking at this next equation, a couple things I want to point out here. First one is this. We need to add 3 to both sides. We need to get this 3 back over to the left side. So what we're doing here is we're attempting to set it equal to 0 in the first place, which we were successful. We are successful here. And we say now we need to factor this expression if at all possible, if we're going to solve by factoring. So solving by factoring, let's see here. I've got a trinomial where my a value is not 1. It's not 1. So what we're going to need to do is a little guess and check. We'd say, what could I multiply to get my 2x squared in the front? It would have to be 2x and x. And we say, well, what can I multiply here and here in the last spots of my FOIL to get the 3? It would be a 3 and a 1. So maybe I put a +3 and a +1. I have to check this now. I'd say, well, if I check this, I get 2x times 1 on my outer terms is 2x, and 3 times x on my inner terms is 3x. And these add up to be 5x, and that's certainly what we wanted here. So since these are the factors here, and this is a factored expression now set equal to 0, we could say, well, then either 2x plus 3 has to be equal to 0, or x plus 1 has to be equal to 0, or both. So solving this one is pretty straightforward. We would say that it's really a one-step equation. We get x is -1. And then here we'll subtract 3 from both sides. We'll get 2x equals a -3, and then we'll divide both sides by a +2. So the x value that is an intercept here, or solution here, is -3/2. So that's how we use factoring to solve equations. You set it equal to 0 and factor it, and then just set all the individual factors in that product equal to 0 and solve those individually. Cheers.